Hi, in this video we'll talk about TriLink, a BigQuery AI-powered enterprise analytics solution. We'll go through what TriLink is, what the data behind it is, what are the solutions we have built, the architecture for them, a few demos of them. But before all of that, I wanted to provide a brief about what the idea behind this is. In today's competitive landscape, enterprises across every industry, whether it's financial services, healthcare, retail, utility, manufacturing, telecommunications, also are sitting on a goldmine of untapped data. It could be structured data sets, or it could be unstructured data sets like call transcripts, support emails, technician notes, customer submitted images, financial data sets, chat logs. These are all logged away in unstructured formats. Traditional data warehouses have served as a passive repositories for this information, but their potential as active, intelligent engines for business operations has remained largely unrealized across all these sectors. Uh, Through this particular demo, what we have built with trialing is essentially a demonstration of how any enterprise can leverage these untapped data sets which they have to create personalized solutions to get ahead of, of the curve. We're showing how BigQuery's native AI capabilities can transform your existing data warehouse into something that actually drives business value. For this demonstration, we have focused on digital service provider space. We have created a fictional company called TriLink. Um, One of the difficult part for any competition is to have quality access to quality data sets. Since I couldn't find anything directly available, I created or simulated the data sets required for this demo. So the company which you have simulated is called TriLink. Um, Trialing, we chose this sector because the sector generates the exact type of unstructured data set that most enterprises struggle with. Here we are working on customer polls, technical support tickets, service interactions, some multimodal content, images, etc. Built entirely on Google BigQuery, we demonstrate how a single unified system can eliminate data silos, leverage native AI capabilities to automate complex workflows, generate personalized customer interactions, provide real-time intelligence to employees. So let's start by understanding what TriLink is, our example simulated company, the realistic slash simulated data set which you have created to power these solutions, and then dive into the 5 different AI-powered actions that show the concept in practice. Now, before we dive into the demonstrations, I want to show you that this entire solution is completely reproducible. Here's a GitHub repository with all the codes, datasets, and the notebooks you need to follow along. The link to this repo will be in the video description. You can clone it and then run it on your end. Uh, the instructions to follow is provided in the README, but you can also follow along easily along with the video. Once you clone the repo, you would see a folder structure like this. So inside the folder called trialing notebooks, that's where we have all the notebooks that we will focus on. Um, so before we start doing the actual BigQuery cool stuff, we have to first set up the process. So as I told, trialing is a simulated company. Um, trialing is a fictional company in Ontario, Canada. It has 3 different verticals: mobile, internet, and home security solutions. So it provides mobile connectivity to like 4G or 5G connections to customers, fiber internet, high-speed internet services to customers, and then home security like ADT, Vivint, which provides like indoor cameras, doorbell cameras, door and window sensors, so products like that. So for this fictional company, first we have to create a data set which we can work on, and it has to be quality data sets. There are some of the functionalities which we look later on, which needs a data set to have certain causality and some correlation between some features. So the very first step which we want to do even before starting everything is you need to have a BigQuery project setup. So assuming that you have that setup, first you go through this simulated um, data set. Um, you set whatever the project name is, you set that. Mine is TriLink, yours would be different, so you just replace it with whatever your project name is for the BigQuery project. Give the database name. It would be ideal if you leave it as database itself, because otherwise there is a particular module which you'll load later. It would be easier to follow if it's kept as database. The very first step which you want to do is authenticate and connect to BigQuery. So run these two steps and you have connected to BigQuery. Um, Before this is the particular step, you create a database, whatever the name which you have provided inside your project. If that database doesn't exist, it is going to create that data set. um, so the first part, or the first data set you want to simulate, is a customer base and the service data sets. So inside SRC, you can see there are few modules. These two modules, like these two modules, they are created with Faker in Python to simulate data sets. I'm not going to go into depth of how the simulation is done. The description is provided here. But the main idea is we want to have customer information. So for trialing, we want to have 100K customers. For the 100K customers, we have first created customer data set which has demographics and some household information, as well as some property information. So for 100K customer IDs, we'll have all of this available. Then we want to simulate and create. So this is 100K customers created. Then we want to simulate and create the data for different services. So there are, some of them are internet customers, some of them are mobile customers, some of them are security customers. So when you run through this, it generates that. So for the sake of simplicity, this is going to take some time when you create it. So you can skip all of this. All the data which we have simulated, it's available in the data folder. So I have commented out the code. You only have to uncomment it. If you want to create your own simulations, I would recommend just run with the data as it is. It took me some time to create it, so you can say that time. So here we create the simulated data sets for the different services. So once we have all of them, we are just going to load it back. If you want to look at different services, internet, we have different contract types. Like we have around 75K customers with different types of contracts, different types of devices in the security data, different types of plans in the mobile. So one of the actions which we do down the line involves a churn model. So we just look at different correlations between certain features. It's just an EDA, and this is mainly done to make sure that the dataset simulation, it was set in such a way that some relations exist for a churn model to be created, and it exists, and all these are logical reasons which we would expect company like this to have from customers. We can skip through most of this. So we have created so far the customer data set, and we have it readily available. So let's load it into BigQuery. So when you run this part, it is going to load this particular data into BigQuery. It's going to load the data, the internet data into BigQuery, the mobile data into BigQuery, security data into BigQuery. In this is just to see that I'm not going to run it because I already set it up in the process, but you can just run all these steps. In this step, you can see the sample customer data sets which we have. So we just print the top 10 rows. We have all this demographic or the property or the home related features. Then this is the sample data set for some mobile customers. These are again, none of this is any complicated information. It's very easy to understand what the columns means. So we have so far we have created the customer and the service data assets and uploaded that to BigQuery. Now the next data set we want to use is call data. This is one of the unstructured data sets which you'll use down the line. We have to it's very difficult to find like call data sets in this particular space from public data sets. So I used Gemini in a two-stage process to create natural call transcripts by adding this, embedding this customers into it. So it's dynamically prompted. If you are interested, you can go and see the call transcript simulator module. So it's going to look at all the customers, and then for random selected customers of around 3000 sample, it is going to look at the patterns and create realistic calls that they would have made throughout the year. Since it's simulated with Gemini, I have limited the call to like 2500 to 3000 records. The purpose is a demo of the whole process, so I didn't want to like bring it up to 100k or something, which is what actually would have happened. So the columns of interest for us is this call transcript. So this is a realistic transcript conversation which would happen, or audio is not possible, or it's very expensive to create the simulated audio data sets. So what I have created is basically the text of the transcripts or the transcripts of the call conversation. So all the calls will have an agent ID, will have the which customer call on what day at what time, which was the agent who took the call, what is the primary scenario, what is the call transcripts, what is the overall rating. So the rating is also created agentically. So this first agent creates a call transcript, and the second agent looks at the call transcripts and provides it a rating of customer satisfaction. Some features used, which was mainly used in the simulation, so we can forget about it. So we have the call data set also created as a CSV. Again, you don't have to run through all the whole process. That is also available as CSV. You can run the notebook as is. You in this step, you are just going to upload it to BigQuery. So there's 2500 calls. So this is the calls simulated for 2025 Jan till 2025 August. We're just going to do some EDA over here. It's different. What are the different ratings present? It ranges from 4 to 8. Then we have here how many calls per month. It's a kind of a uniform distribution, close to uniform distribution across 8 months of 2025. Then you have to create a connection, vertex AI connection. So this is important for creating using any of these Gemini models or the ML embeddings for any vector search. So you have to run this particular process, and before running this, you have to go to IIM and provide your BigQuery account access, vertex AI access, provided you are using vertex AI for the connection, for accessing the models. Now with this step, you can actually create an embedding models within your BigQuery project. I'm using text embedding 005 from Google. It's a pretty good embedding model, and it works pretty well for this particular domain. So now I have the call data sets with the transcripts ingested to BigQuery. I have the model available. So next step is I'm going to create another table with the embeddings also added for the call transcripts. So that is going to be this call transcript row embedding. Then here I'm just going to do a quick demo. I want to look at this is not the actual solution, just testing everything is working here. So from the call transcripts embeddings, I want to see what are the calls that have a rating more than 6 that is most similar to this particular kind of like customer experience, a complete service outage for 3 hours, so and so. So this is going to return as the cosine distance. So it's going to return the top. I limited by 5, so it's going to return the top 5 calls that are similar to this issue. So if we just hover over this one, yeah, it's similar to that particular topic. Anyway, I have just printed out the calls, so you can just scroll this and read through this. So we have the call transcript created for the first 8 months. We'll again run this one more process to simulate the call transcripts for the 2025 September. The reason we separate it out is that the actions for the down will be created based on this particular call transcript. Um, this is because we don't want to, it's not going to be in cheating, but treat like traditional ML space. We want, this is a data set on which we'll be testing our solutions which are built on. So we don't want any, we want it to be completely out of time sample. So this particular process again reruns, creates a calls, like around 300 calls for this September 2025. We just append it back into the raw call transcript, but we are not going to add it into the embeddings table. That's a pointed out later. And here is a frac of the total calls now. So now we have added in 357 calls for 2025 September. And for September, every day we have, um, it's not uniform, but like max 20 to 5 to 20 calls per day. So this is the process of setting up the call and the customer data set. Now the next part is we need to set up uh, some solutions data sets, or the business solutions or technical issue solution data sets, which we will later use with some vector search. So this is not complicated, you can easily follow along. So these are different pandas data frame. I'm just going to rush through this. These have basically different problems the customers could experience and the business solution to that. Um, this is available across all the three sectors: mobile, internet, and home security. So the data set looks like this. Problem, what is a problem the customer could face? What is a solution the business offers to this problem? And what is the internet? And this is ideally considered as a dynamic business solution data set. As businesses finds new solutions, they can add information into this and subtract information from this. um, we will be using it later in certain cases where if we find a customer solution, instead of randomly picking through a cookie cutter solution for all, we can look at what the problem is, then we can do a vector search to this problem and find the solution, add it to the solution flow. So that's a whole idea behind this. We create that, add it to BigQuery, same story as before. Then we are just testing, we are creating the embeddings for that. Then we're just doing a test of that. So again, we'll just go into the next one. So this is similarly, the previous one was for the three sectors: business solution, problems, and business solution. This is a bit more different. This is specifically for the home security one. So this is mainly for helping understand the different problems that comes in the security devices. So in this case, the ADT command panel shows system, battery, then what are the solutions to solve this. So we will use again later uh, for some specific technician assistance or customer assistance to fix the devices. This will be used. So again, the basic idea is similar. We create the data set, add it to BigQuery, create embeddings, test the embeddings are working, and that's it. And the last step is this is more of a multi-model solution. So we wanted to create a few active tickets in the home security sector. So customers, when they have an issue, they usually, in this particular domain, they usually either call the agents or they go to the app and they create a log of what the issue is. But oftentimes the issue, this is a bit of more technical system. The issue log by the customer could be maybe simple, like my security panel is not working, but that might not be the actual issue. So often it's advised the customer also snap a photo of the issue. So we are going to have the ticket ID, the customer, and what issue the customer um, has mentioned that they have, and then an image. So since again this is a simulated data set, I don't have an exact image for the issue which they describe. So I have an image generation prompt here instead. So in this process, I'm just going to use that prompt to create an image from the point of view of the customer, as if the customer would have clicked using Nano Banana. You don't have to run through this. So the whole process is ran, the data is available in data folder under images. All the 100 tickets have 100 images associated to that. So let me just scroll through this pretty fast. We're just going to, one step you have to do is you have to go to GCS Cloud Storage, create a bucket. It would be easy if you name the bucket as TriLink, but if you name it as something else, replace it here as well as here. This function is going to upload all the images to the GCS bucket, and then you are going to this, and that function also returns this particular data set back, which is essentially what we want, which is the ticket ID, the customer ID, the technician ID who is assigned to solve the issue, what's the issue description provided by the customer, and the URL or the GCS URL of the image associated to that particular ticket, which we simulated using Nano Banana. Same story again, using it back into BigQuery, and that's the last of the data simulations. So we have created these many data sets and we are uploaded back into the BigQuery. Now that we have the data sets, we will just go through the last step to set up the space. One of the solutions down the line is going to do some personalized retention. So in order for the retention, instead of randomly assuming that the customer's problem is XYZ, if they call, we could get some idea from the call transcript, but majority of the customers might not be calling for the churn. So, and businesses have a lot of churn models running. These churn models are probably very good in identifying who is going to churn, but it also has a lot of capability. But oftentimes what happens is it's those capabilities like SHAP or the explanation behind it's very technical. It's very difficult to translate into marketing or the retention side. So the probability goes into treatment bucket, and the treatment for all the customers are going to be same. Instead of that, the idea here is that we are just going to use the model to predict every customer's probability to churn, as well as using explain predict, which is a functionality in BigQuery. Also predict what are the feature contributions, so the contribution of different features towards churn. And if you know that, we can get an idea of what are the reasons to churn, and if you put it into an LLM, it could be able to put it into a proper description what the customer's issue is. So that's one of the idea down the line. So in order to do that, we first have to create a churn model. Again, you don't have to do anything, you just have to run through the process. We're first going to create a view by combining. We're going to create it for the mobile customer. So we're going to create a view by combining the mobile services data and the customer data set. We just doing some frag check and everything. We're going to create a boosted tree classifier similar to XGBoost in Python. The target variable is mobile churn. Not doing anything fancy here. We just want to create a simple model for the demo purpose here. Then we just want to see like the prediction is working fine here and what ML explain predict in BigQuery provides. So in this case, for this customer, we have predicted the churn probability is going to be 64.6. But we are more interested in this particular one. This ML.explain predict, it's going to provide what is the contribution of top 5 features. That's one of the things I have added in the survey. The feedback, it would be nice if you could have more than 5, but it's kind of limited to 5 features with the highest magnitude. So more positive magnitude here means it's pushing towards churn, and negative means it's preventing churn. So we are going to prompt according to that. But basic idea is if you put this and the customer context into a prompt, it is able to understand and create a description of what the customer's issue is. Now, if you run through this, there's also the similar thing for the internet customers, which is same. So you can run through that or not. So this is, once you have followed so far, great. You have set up the process. The cool stuff is now going to come. Okay, now that we have set up our wall environment, let's go to the BigQuery Actions notebook. So this is where the entire stuff is happening. Um, so the very first action, it is, I'm using the word actions a lot here. So I have 5 different solutions built with BigQuery AI. I'm calling them as actions here, 1, 2, 3, 4. So the action one is creating a follow-up or the next best action email. Um, the idea here is that a lot of customers, they when they call, uh, if they had an issue and if the agent was able to solve the issue or not, uh, they might not be always super satisfied with the solution. They might not have understood the actual solution was. It could be possible that they were satisfied and there was an opportunity to do a cross sell or an upsell. In our case, if they call with an issue with the mobile and we solve the problem, it could have been possible for us to upsell them for a home security device. So a lot of options are there. So the primary objective is always to make sure that we want to reach out to a customer who needs this and tell them, yeah, this was your problem. We understood that the agent have done solution XYZ to your ABC problem. And if it seems appropriate to provide a cross-sell or upsell recommendation to the customer, we'll also want to add some specific information. So this is the overall structure here we are going to follow. The LLM we are used is Gemini 2.5 Flash in BigQuery AI. The embedding models, again, we discuss is we using text embedding 005 from Vertex AI. So first we take the call transcripts for a particular week. The idea is it could be weekly, it could be daily, every day. At the end of the day, we can set it as a start procedure, runs and creates a table. But in this case, you're going to take September week, the last week, 14 to 20. We're going to take all the call transcripts. First, we are going to use a AI generate bool function. We are going to put the call transcript it and ask it in a detailed prompt, does this call need a follow-up or not? If it's a payment, um, like customer call to make a payment, we don't have to effectively reach back to them. So we look at a yes or no solution. If it's not needed, we are dropping it from a base. We don't want to waste tokens on that, and we don't want to like hit the customers with unnecessary emails every time. If it needs a particular follow-up, we are going to look at 3 cases for each of these calls. First, we will create an embedding for the call transcript. Then we do a vector search for the 3 similar calls in the past. This is the reason why we split up this call as like train and test in a realistic business. Um, in September, the calls, if you want to look back for solutions in the past, it have to be before September. So we are going to look at 3 similar calls in the past from 2025, Jan till August, with high rating if it exists. So we are going to limit um, looking at the calls greater than 6 rating and has a cosine distance uh, which shows high similarity. Similarly, we are also going to look at top business solutions. So we are going to do a vector search of the call transcript towards problem embeddings. At the same time, we are also going to look at the customer, and then we are going to create some data aggregations of the customer, what this demographic of the customer is, what services they are on. This is mainly for the cross-sell side if it seems suitable. And then we are going to pass all this into an AI generate and then pass the primary call and secondary call. So for all these customers that came through that filter, we are going to create personalized email, which can be easily connected uh, to the tool, marketing tool of choice. So this is a BigQuery code for this. Um, the This is a prompt where we are going to check the AI.generate bool. We are very um, conservative here. We don't want to take out any calls that could would in any circumstance need a follow-up, so we prompted it in that way. This Once we have that and filter to the data of interest, then we are going to create the embeddings, um, create the embeddings of the call. Yeah, we are going to look at the similar calls for this, similar calls in the past with high rating for this. We're going to look at the um, best solutions uh, for this particular from the business solutions. Here we are creating the customer portfolio, like we mentioned, what devices they have, which all they are on. So we have all of them collected. Now in this particular query, we are just combining them into a final base table. Then on the base table, we are using add or generate to create a personalized email. We pass the customer information, we pass the current services inside this, we pass the current call transcript, we pass a similar match problem, recommended solutions, we also pass like what are the available upgrade, upsell, uh, cross-sell options are. Then we pass like what are the similar calls in the past which were successful. Then we put some notes, just as like we normally put in any prompt, to have the email in a proper format. So this runs pretty quick, because we only have like 300 calls in and like 100 calls in a week. But again, it ran for me like in under a minute. Um, in this particular step, I ran that and I have saved it into a particular table called follow-up emails. I'm just going to run this and pull it into a pandas table to see like how it occurred for some customers. So this is a out of like 98 customers who called, 37 were deemed to have a follow-up. So this is the wall process, the current call transcript for the customer, the similar calls we found, the similar match problems we found, the recommended solutions, personalized emails, so and so. Um, Instead of looking through pandas tables like this and hover over it, I thought it would be easier to put some examples here. So this particular customer called on um, technically day before yesterday. This was the hyper personalized follow-up email we sent to them. We say that we understood what their issue was here, we sincerely apologize, so and so. Then the agent discussed this particular thing with you. Um, sorry, the agent particular discuss this particular thing with you, and then like this is a part which comes from the business solution. It identified that any issue like this, business solution was to provide a particular credit to the account, so and so. And just for reference, these are the similar problems which you mentioned. Like I'm just printing out all these things so that you can verify it works. I printed out it for a few more customers just to make sure that it works. So just to put it into a value perspective, this demo is ran for 96 calls, and 37 calls was deemed to need a email fallback. Assuming like we have a $5 value uh, for a call taken by an agent, based on the time as well as the resources agent needs, and assuming that a 3-year value of a customer is 700, and potential cross-sell or upsell is going to add $500 into the customer. We are also doing an assumption that 5%, this is not an assumption, it's the actual churn in the data set, 5% churn in the actual data set. So we are going to assume a similar churn with no follow back email could have happened. The actual value lost is $12,900. Then the 50% of the follow-up group assumed to have callback without follow-up. If we make that assumption, like if we wouldn't have sent them email, the next day they might have again call back, then it would have cost them, there is a star in here, actually it doesn't, yeah, it is going to cost them 370 times $5 times 50%, $25. So I made an assumption again here. I might have made a lot of assumptions so far in this context. So again, the simulated calls, the frequency is very low. For a company of 100K customers, it could have, instead of 96 calls in a week, it would have, I'm assuming it's going to have 10 times a call. So all the calculations is multiplied by 10. So overall, long story short, with this approach, we seem to be saving like 23K per week for this 100K virtual company. And if we extrapolate it through the entire year, assuming the same pattern follows, it's going to be saving like around $2 million. All these details is provided in detail in the much more detail in the write-up. So I'm going to skip through to the next one. So this is weekly agent performance evaluation. So here the idea is the call center agents, they are taking this call, and there are supervisors for this agent. So the supervisors, they manually have to go through this conversation. Sometimes the agent happens to guide them, understand what could be the things that they could improve, what could be the things someone is doing very well, that yeah, this should be done by others as well. So it's a not an efficient solution, but there's a lot of data available for this, and a lot of time of the supervisors are also wasted, as well as agents learning from each other. It's a bit limited. This is a hypothetical idea. So the process here is that the same call data set, the same weekly transcripts we're looking at, we are going to create embeddings for that. We're going to do the vector search, and we are not limiting for the 37 calls before. We are taking all the 96 calls. We're going to look at the vector search for the 3 similar calls in the past among all the agents with high rating. We're also looking at the top business solutions. Then for each call, for each agent, using AI.generate, we create 3 different columns. One, what was the positives, what agent did very well in this call, if there was any. Then what agent could have done better, which is the negatives in that particular call. And then another column which is what the agent could have done better in this call. It's kind of a coaching material. And this is done first for all the calls. Now we are going to aggregate all the calls, all these columns, 3 columns for the agent across the week, and then pass it into another AI.generate, so that we get a weekly positives for the done by the agent, weekly negatives done by the agent, and coaching recommendation by the agent. So at the end of this whole process, we are going to create a table which will have all the agents. In our case, we have 10 agents. All the 10 agents, what were the positives they have done this week, what were the negatives they or negatives or the what were the drawbacks of their approach this week, and then what a kind of a coaching material to improve on their positives. This is available to the supervisor, so they can easily look at this and then provide guidance towards the agents. So now going through the code, we are first going to filter the call data again to the period of interest. Now we are creating the embeddings for the calls. We are doing the similarity search for high performing call, see as before. We are going to do the vector search for the best available solution. Now that we have both of them, we are going to create the positives for each call. We are going to analyze the negatives for each call. We're going to suggest better approaches or the coaching materials for each call. Now once I have it created for all the calls, we are going to aggregate it. I haven't used AI.generate table here, and I have used AI.generate instead of generate table, mainly because I wanted to have flexibility in this particular prompt, which is a bit difficult to have in AI.generate table, but that's also an option. What I did is I just did a concat so that all the contents, all the columns are appended together, of the weekly positives, sorry, all the positives and the weekly positives, and the AI.generate is it as weekly positives. We have the weekly negatives here, and we have the coaching recommendations. So this is going to save into this weekly agent performance table, and then I just ran again, brought it back to a Python table, and this is the wall output. So it's going to give us for each agent how many calls they took, what is their average rating, how many successful calls were there, what is the success percent. These are all facts that were already in the table. This is not coming from the AI generated part. These are the stuff which we are interested in. So weekly positives is for each agent, what were the positives they did, what are the negatives they had, what the coaching recommendation, 3 to 4 specific points. That's what we prompted. I also printed out some agent examples. The idea is, again, they are not only you're not only telling them what they could learn from. We are also providing what they excel at. We're also going to cross-reference something agent A excelled at and add it as an option for agent B to improve in any specific situation that comes later. So that's action 2. Now action 3 is ML powered um, personalized retention email. So this is, we briefly talked about this before when we created the churn model. So the idea is we take in a subset or any particular population we want to do the retention campaign on. In this particular demo, I'm going to look at customers, like young customers who are working from home, who have a tenure of more than 1 year. So let me go through the whole process. So first step, we take that particular subset, we score the XGBoost model, um, not using prediction, ML.predict, we use predict explain to get the feature contribution. Now that we have the probability of churn for the customers as well as the feature contributions, we're going to filter only for high probability churn probability customers. We don't want to send the retention email to all of them, so we filter for high churn probability customers. We pass it through um, the feature contribution as well as the customer features through an AI.generate prompt to convert the technical risk factors into a problem solution. So we want to create a wording of what the customer's problem could be. So this is going to be useful. Now you can see here to do the vector search for the business solutions table, as well as uh, we are going to collect some customer information, like what all products they have, whether they have mobile, internet, home security. If they don't have, in the retention, we can embed some cross-selling options. Also, by adding them additional offers, by like bundling particular products. So all these three, which is basically the textual description of what the customer's issue, which we identified from the ML model, the solution to that issue recommended by the business solutions, and the customer's current status, all this goes into a personalized retention AI.generate prompt, and we have a personalized email created for the customer. So in this part, we do the explain or predict. Here we do the security services, internet services, and mobile services aggregation to get the customer product information. And then we pass that um, product information as well as the feature attribution into this AI.generate to get a problem description. Now we pass this problem description, um, we create an embedding for this problem description, then we do a vector search of that problem description's embedding with business solutions to find what are the best solutions for this customer. And then once we have all that, we are going to consolidate it into a table, and then that base table, then for that particular base table, we are going to use an AI.generate to pass the customer information, um, the churn risk factors, which is churn probability, which you already know, then the top feature attribution, the similar match problems, recommended solutions, so and so. And then we also do the similar primary secondary goal. Like primary goal is always to prevent the churn, secondary goal only when it seems ideal to the cross-sell pitch, and some wording limits and some uh, formatting guides. So this runs again. Again, this was ran for like around, started with 960 customers. Um, 96 customers. Then it came down to, started with 1,000 customers, who are customers for more than 1 year and have work from home and are less than 30 years old. Then uh, we filtered for the customers who have high churn probability, for which the email is needed. That was 22 customers. So for those 22 customers, um, we have this table output created. So all the info is here. So if you look at the problem analysis, this is the wording which the AI.generate created by passing the ML feature contribution. Um, and this is the final email. This is the top feature attribution we got. So instead of looking through the table again, I've just printed out a few of them, some random customers. I haven't handpicked any of them. You can look at what the problem analysis identified was for this customer, the personalized retention emails under the customer addressing this particular problem, and the top feature attribution, etc. So that's a third action or the third idea. The fourth one is the automated ticket handling for home security. So this is the idea of, part where we discuss again briefly this idea in the data simulation part. Uh, Customers create tickets via the app or with the agent's help with the issue description. They could also be, or they are in this situation, they are also asked to upload at least one image of the issue. Then the idea here is a lot of these issues might be simple, or some of the issues what the customer mentioned might not be the actual root cause problem. So it would be really nice to have a system where we can, can we solve it remotely instead of sending a technician? B, can we, uh, if it needs a solution, can we somehow have the technician to have a heads up and to provide them an understanding even before they arrive, what could be the solutions, or what could be the things that they have to do to solve this problem and what exactly the problem is. So the idea here again is we have the customer ticket table with the issue description and the image of the issue snapped by the customer. We're going to do multimodal data prep on that. We're going to convert all the images in that using the object.fetch metadata and the object.make ref function, with the multimodal part of BigQuery. Now, once you do that, the image is basically a queryable object now, just like the text. We can easily put it into a AI.generate or AI.bool function. We're also going to pick the customer profile. It's to get some personalization further down the line in some messages or something created. So we are going to combine both this into and add it into an AI.generate. So all the tickets that came in a week, we're going to put that by passing to this pipeline into an AI.generate table. We are asking it to simply, these are simple prompts. We're just going to ask it to identify what device has the issue, what is the issue type, is it a software or hardware, what is the urgency of it from 1 to 5, 5 being the most urgent and 1 being the least urgent. Does it need a site visit by technician, which is the core thing which you want. Like if it sees that it's like a software issue, there's no need for a technician to visit. Now if it needs a technician visit, then I create a report for the technician. If it doesn't need a technician visit, we still need to solve the customer's issue. So let's create a DIY instruction on how to solve this. So this DIY instruction can be either sent to the customer as an email, or the agent, customer service agent, could call them back and take them through this step by step. So the DIY instructions have to be simple enough. So this whole process is then saved into a table which can be used on demand. So before we start this, we have to create a Gemini 2.5 Flash model connection, because this is when we use the multimodal analysis, we can't simply use a remote connection. So remote connection indirectly, we have to create a remote connection in the BigQuery space. I could be wrong here, that we could directly use it, but I followed one of the sample notebooks provided. This that over there it was specifically mentioned in this way, and without creating the remote connection, when I was trying the same way and error.generate, I was getting an error. So anyway, if you run this, you won't face any error. It could be a little more better solution. Um, Let me know if you find anything. Now, once we have that, we are going to load the tickets, customer tickets table. So these are tickets, these are the issue, this is the URI of the image, which is stored in cloud storage buckets. Um, we are just going to do some sorry, we have done the mapping of the customer base information, as well as we created the image ref object. So now our table has few more columns. So this is the image ref object, and these are the demographics data which we added from the customer TF table. Now once we have this, we are going to pass it into the air.generate table, asking it to create a device name, hardware, software, need on-site visit, urgency, technician report, DIY instructions. So it's important that you make sure you put the data type you expect for it to come. Like uh, if you don't put it as bool, need on-site visit, it might be an issue later down the line, because sometimes it comes back with capitals and small letters when you put it as a string. Similarly, for the urgency, it have to be an integer. Um, so now we have created a table. So, and this table is basically what we want. So now we are going to load that particular table. So all the tickets, now we have the issue description, device name, whether it's hardware or software, whether it needs an on-site visit, urgency. If it needs an on-site visit, technician report, vice versa. One thing which I have noted is, even though we told in the prompt that use technician report only if it needs a site visit, it always doesn't follow that. It is sometimes, it even if it doesn't need a technician visit, it's going to create a technician report. I don't have any, I don't think it's a huge issue. We can limit it by logic itself based on this particular column. If this says no, don't look at technician report, just use DIY instructions. So in our case of 100 tickets, what we found was that 62 tickets didn't need a technician to visit. It could be done by DIY instructions. So what we are going to do is, okay, I'm just going to print out some random tickets. Again, I don't think I have done any hand picking. I'm just taking like random samples here. I'm just printing what a ticket issue was. This is the um, this is the issue that the customer has mentioned. This is the device identified by a .generate table, type, urgency, etc. And this is the image, technically quote unquote clicked by the customer, but we generate using Nano Banana. This one deemed to be needed an on-site visit, so we are using the technician report. The technician report is also supposed to follow a format we prompted in that way. What is the issue verification, whether it's correct or not, by looking at the image. Then the severity of it, what are the required tools for this. I mean, this is a prototype. Ideally, this needs to have mapped to some other RAG base also. Then a step-by-step repair actions and estimated time. So idea is technician, when they get this, they are already prepared. Yeah, this is the problem. This is basically what I want. If the solution here is exactly not complete also, they will know the problem and they could prepare themselves ahead of time what is needed. Similarly, I just printed out a few more cases here. So that's that. And the last action, action 5, is a BigQuery AI powered ADK agent as a chatbot. So we discuss a lot of things, a lot of table creation, etc. using BigQuery AI. All these things are kind of a daily process or a weekly process or a scheduled job. But we can easily add all these as BigQuery tools. So my idea here was to create an ADK agent which does real-time solutioning. So be it a customer uh, who called and they said they want to churn. Our churn model didn't run for them. We don't have a personalized email solution or anything created for them. So what does agent do? In a normal situation, agent would follow cookie cutter retention script or the rules they follow, and chances are the customer is going to churn. But if they had a chatbot which could basically they just have to ask what should I do for this particular customer, if it could go and run the model, create this personalized message to convey, it would be awesome, right? So that's the idea, not just limited to that particular churn, but a lot of different um, BigQuery AI functions that would be awesome to have on demand. We are going to add these are tools to agents. So ADK, to provide a brief, is Agent Development Kit. It's an awesome agentic solution which came available from last July. I use it a lot in my work as well as in some of the hackathons I participate. So we're going to create 3 agents. Um, we have a bunch of tools. We'll first go through what the ADK agent structure is. So we have a main agent called TriLink Assistant, and this TriLink Assistant is basically a router which has 2 sub-agents, call center agent and the field technician. So the ADK agent which we have created is to help call center agents or the technicians. The call center agent is provided with 4 different tools. One to get customer info, one to get a retention script, one to get business solutions, one to get ticket solutions. And then the technician is connected with 2 tools, tech reports tool and tech solutions tool. All these tools are basically BigQuery AI in the backend. It could be AI.generate, it could be vector search, it could be BigQuery data, basically data query. All this are connected as tools. Also, I put a brief of what all the tools are. Not going to go in detail. I'm just going. We already discussed retention, so I'm going to look at the tech reports, for example. What this tool does is it takes a tech ID, technician ID. It's going to join with the ticket solutions table uh, and get the ticket, like the solutions created, like technician report and everything created for that. Then it's going to filter for the city on demand, which is done by ADK. And it's going to sort by the urgency, and it's going to return the tickets and everything for technician on demand. So, I mean, you can go through all these tools if you are interested in the write-up. We have explained it in a little more detail. Um, so let me show some demo. So first, let's keep take a case where the call center agent is going to use the ADK agent. So the call center agent basically first asked, I'm a customer agent, tell me who this customer is. So a customer called in, random customer number picked. So what it does is it's the main router agent. It identified that um, this is ADK related actually. So it's identified that this is a call center agent related. So it send a task to the call center agent. It knows in its prompt that if the question is about some customer information, go and look at this customer info tool. So customer info tool is basically going to map at this, look at this particular customer's different features, demographics, services, etc. And that is put into an AI.generate to create a summary. And that summary is then passed back to the agent, and the agent sends it back to the user. So for that particular question, this is a summary the AI.generate created in demand. So this is, you just have to pass this particular customer ID. This is going a bit into ADK, so I'm not going into the depth of ADK, but simpler idea is ADK enables us to use BigQuery as a tool, or BigQuery AI solutions as a tool here. Now, any customer that calls in, instead of wondering and asking the customer or following some cookie cutter information, you already have an idea about summary of who this customer is, what services they have, and what are the potential upgrade opportunities available for this particular customer. This is prompted in the tool. Now, this is an issue that this particular customer is facing, hypothetical issue again. So what it does again, the agent is not doing any, the call center agent is not doing any hand lifting. It just asks the ADK agent, yeah, the customer is experiencing multiple overage charges. What is the best solution for this? So what the ADK agent does is again goes through call center agent, identifies that yeah, this is a business solution related information. So it goes and calls this business solutions tool. So the business solution tool is going to create an embedding of the question from the customer, and then it's going to do a vector search of that embedding to the business solution table, identify the best business solution for that particular issue, give it back to the main agent. So it's pretty cool because it's kind of difficult to do this without the BigQuery AI, because these are in a way a bit structured data sets, but we in a normal Python agentic space, we need to have the whole data set brought back in, then create another Gen AI functions or the like model call, API call with specific prompt inside the tool which we create, and then return back to the agent. Here it's pretty neat because all this AI part can be done in BigQuery itself. So the output from BigQuery is basically what we need. So we don't have to do any hard lifting with ADK. We are not worried about any exceeding token cost. So yeah, I'm pretty impressed with this, and I like this as a good solution uh, in some of the problems we have in our work too. So next one, we are just the same agent is going to ask, help me solve this home security tickets for this. Again, the wall process, it identifies that it's a issue with ticket solutions. So it's going to use a ticket solutions tool. Ticket solutions is going to join all this active customer tickets. It's going to identify the resolution knots created from the tickets we had before. It's going to return that. This particular tool, it's not readily using any AI, BigQuery AI function. It's using BigQuery to load the data. And this is the last of the customer agent usage in the ADK app, and the sample we discussed initially. So this is pretty nice. All the agent have to ask is that, yeah, this particular customer called me and he says he wants to churn. So what should I do? When the agent asks the ADK this, ADK is going to invoke this retention script tool, and this is a retention message tool. So this is going to follow the same process we had discussed for the email solution, but only difference is we are filtering first of all for a customer, so it's going to be pretty fast. And instead of an email, we are going to prompt it to create a retention script for the agent to follow. So it returns, does the prediction, identifies what are the possible reasons for this customer to churn, the word flow, the word story, and it returns to this agent call script to follow. So the agent can, like, it starts with appreciating who the customer is, like they have been with us for so and so period, then identify what the problem was, and specifically designed product for this particular XYZ. It also provides like if this is not accepted, this is the backup. So it's pretty detailed, and this is all created by a.generate in BigQuery. You're not using any other function calls here. Now similarly, instead of customer agent, if the technician wants to use a live AI tool, technician can also just again use this ADK app and then do it, just ask, I'm this particular technician, give me details of all the tickets open for me in Toronto. So it's going to go and go to the technician assistant, and then the corresponding tool is going to pull up all the tickets associated to that, and then it's going to put it in a particular proper format that, yeah, this in a decreasing order of the urgency, that these are the devices affected that is assigned to you and needs a technician visit. This is the issue verification, this is the estimated time, so and so. Similarly, technician can also leverage the technician, um, ask basically the ADK agent any doubts that they have in the devices, like issues when they are solving, like outdoor camera feed is exhibiting, so we are flickering, what should I do? So it's going to go into uh, look at the tech solutions. It's going to convert the technician's questions into embedding, doing a vector search of the tech solution, or the technician's questions to the tech solution, sort by distance, provide the top, like the most similar solution to this, give it back to the ADK agent. The ADK agent will analyze that, the questions of the agent, and then is going to provide the answer to the agent, that these are the things that you can do. So these are all the 5 actions that I have created with BigQuery AI. There's a lot more that you can build. You can create a one of the ideas which I wanted to implement but thought it's too much, and time was also not there. It's basically weekends. Was that to create a recommendation engine, like we have 100K customers. Some of them are internet customers, but not mobile or home security, and vice versa. So uh, put them into all a vector base, and then um, find the customers who uh, bought, who had internet, uh, but don't have mobile. The customers similar to that bought these particular products, like they might have bought indoor camera, or they might have bought uh, the home security device, the um, window sensors. So basically we can create a table which for all the customers, 100K customers, we can have what is the top one product, two product, three product to recommend, like by rank them. um, that's I mean, we necessarily don't need a vector database for that, but it's a neat solution. There are a lot of things that can be done, so that's why I started with saying, like, enterprise businesses, um, this is using BigQuery AI is going to be a with this they're going to be able to uh, touch a large sector of data which they are not touching with the agentic solutions. And we also see BigQuery AI can be used as tools in an agentic system itself. So the opportunities are endless. Uh, if you have listened so far, thank you for listening to me. I know it's a long process and I found it difficult with the limited time of the constraints of the competition here. I found it like difficult to edit it into like a 5 minute or 10 minute video, and considering that we have to discuss the whole different solutions, it took around an hour. But if you follow me so far, thank you for listening to me. uh, have a good BigQuery day. Thank you.